Right. New model. This I'm going to model a truss. So a truss will still be a plain frame. And I will set up, now this is going to be 12 meters long. And this time, and it's going to be, let me draw it. So I'm going to specify my defaults as being not beams but bar elements this time, because with the truss we only worry about axial loads. I am going to join up those two endpoints. So this is the bottom boom of my truss. I'm then going to select that, and I'm going to copy it up in the Z direction by 2 meters. That's okay. And then to add in all the diagonals, I want to break these elements down into smaller pieces. Now the bottom one, I'm going to use this split elements tool, and I'll break it up into 3 pieces. And then this being a Warren truss with all diagonals, I'm going to get the top one and break that not into 3 but into 6. So I can then just snap to the nodes. In fact, I'll also change my property numbers to second number, and I hold the control down so I can keep going. To then draw the truss in. Now these being bar elements, okay, I can delete out those end ones. These being bar elements, because they carry axial load only, these node points here would actually be unstable. Yeah, bar elements carry axial load only. They have no bending stiffness. So apply any compression load onto those points, they would automatically buckle. So we have to prevent that by joining up those elements, and there are a number of useful commands under the sculpt menu. In this case, it's the 1D elements join string of 1D elements, and this will look for elements of the same property, collinear, and the individual nodes have not been used, and so that middle node was being used by the joint. The other two aren't, and so we can then join those up, and I'll just delete out those other nodes from the truss. I need to make sure we give support points. So that point there pinned, that point there. Now this time I will just give it a Z stiffness. Did I not? Okay. Otherwise, in this case, I would get a very different result if that didn't have that horizontal reaction. I will now apply some point loads to the top, and I'll select the nodes. Yeah, there is option to copy as a list. In fact, I mentioned about list. Let me save selection as list, and I say load points. This then creates a list down here, which if I switch the node numbers on, you can see that that list contains node points 7, 9, 11. I can then go and create these loads in the load table, and you see, because there's a list there, I can then select that list. case one. Oops. Make sure we do have some load on them, and always check the load arrows, because it's very easy to put the loads in with a positive number and therefore end up having loads going up rather than down. So analysing this, if I was to give sections first of all, I'm going to use I'm going to use a catalogue section there, create a square hollow section. Now the square hollow sections are stored down in the EN10210 catalogue. Square hollow sections, let's say 50 by 50 by 5, and then the diagonals will then be similar but a smaller section. Well, let's say 40 by. Actually, that'll do. Quite slender, but it's quite a light load. And analysing that, we then can see deflections. Under the contours, we get things like the axial force, or alternatively we could have the displacements and so on. So that there's a variety of contour results and also diagram results, either through the buttons here or through the diagram settings commands here. Actually, reactions. Let me call up the double clicked on the screen to get the graphical wizard. I'm going to exclude the legend panel there, so we can see the this is the legend panel, so I can see all the model a bit clearer. I'm going to change to let me clear that. I'm going to call up the diagram for the contour, so nodal results, reactions, resolve reaction. You can see there the resolve reaction under the applied loads is vertical as we expect, but in this instance, if I had taken that node and give it a full pin, you can see without getting quite large horizontal reactions from this structure, and likewise the axial force is now very much going over top. So it sort of changed from being a truss to an arch by adding in that horizontal reaction.